All right, guys, so on to the video where we are now looking at page 54, trends and observations of reactions of period 3 elements with oxygen, water, and chlorine. Now, if you can do the crossover method quite confidently, this is where you're going to test your practice. Remember, it only works for ionic compounds, so metals and non-metals. It doesn't work for covalent, so these, because these are non-metal and non-metals, they're covalent. So we can't use a crossover method for those, unfortunately, but we can for every single one of these. You can already see the gaps. You already know what I'm going to say to you. I want you to use the crossover method that we learned in the last video to complete and balance these. These aren't balanced, so even if you get the product, which is available to you, you need to then balance those. Please have a go at this now. Right. Now that we've come back, I want you to balance these ones, which are also our covalent reactions. Just double check them, make sure you put the numbers in the right places. Now, just before we do that, I want to talk to you guys about the observations. Now, these are typically going to be 1 markers, but you do need to remember them. And they're quite easy to remember. And what I'd like you to do for this bit is in your booklets, can you colour them in? I made these pretty little diagrams to colour them in. I've also realised that most of them are kind of boring because they're just like white solids. However, sodium. When I react sodium with oxygen, I see a yellow flame. So I would colour that as a yellow flame. Magnesium, aluminium, silicon, and phosphorus, they all have a white flame, which is blank. Maybe you can find a different way of colouring it in white, but it's a white flame. And then we've got sulfur, and that is a blue choking gas flame. So it's a blue flame with acidic choking gas, and they're kind of the symbols I've kind of drawn out for you. With the reactions, you're going to need to know how to balance them, how to predict the products, and predict the observations. And they could ask you something like, we burned a substance, and it burned with a white flame. Can you predict which of the products, which of the reactants we might have used? And you might think, okay, it might be magnesium, it could be aluminium, it could be silicon, it could be phosphorus. And they might give you some other information where you need to then process which one of these is it going to be. They could also just say something really straightforward, like if I was to burn or react sulfur with oxygen, what colour would the flame be? Yellow, white, blue, green. And you would just have to tick blue. So it really depends on how they ask the questions, and we'll see how that comes up in the exam. But this is everything that we need to know. Now, the next sections that I'm going to talk about is going to be very, very similar, but these are the reactions with oxygen. We're going to now look at reactions with hydroxides. Remember, hydroxide is a polyatomic ion. OH minus stays together. We don't separate that out. So the OH minus stays together. You can use the crossover method to produce this, and I'll tell you that the sodium is going to be sodium hydroxide. We're going to produce magnesium hydroxide, and then aluminium hydroxide. It also produces hydrogen gas in every situation. So if I mix it with water, we'll see hydrogen gas coming off of that. So the reactions of the metals with the water, we are going to see some observations that we need to make a note of. And I figured it would just be better for me to say what they are, and then you write them down. Unfortunately, there's nothing exciting about that. Hopefully, we can demonstrate them in class. When I react sodium with water, it reacts violently. You might have seen this where someone puts a bit of metal in water and then it just blows up. It just goes into a big a big yellow-orange flame, and it might ignite itself. And that'll be sodium. Magnesium is less reactive than sodium, so we'll see a slow reaction, but we will see some kind of like bubbling and some type of reaction there. And for aluminium, only the outside layer reacts. That's it. Very, very unreactive. There's a few ways we can explain that, but what I thought would be quite interesting is to use location cars to discuss that trend. I've laid out the table here, and what I'd like you to do instead of typing it and writing it, because you've done it enough, is I want you to draw arrows to represent what happens to the nuclear charge from sodium to aluminium, what happens to the attraction, what happens to the radius, the shielding, and then the ionization energy. Remember, ionization energy is the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms to form 1 mole of gaseous 1+ ions. The last one I've got to talk about is the reactivity with H2O. Once you've done the location cars, it'll become much clearer why or how the reactivity with water will change. You can use the observations, and it's quite clear from the observations, but you can also explain it using location cars. just to give you a bit of update, in order for sodium, magnesium, and aluminium to react with water, it needs to produce sodium hydroxide, which is going to be sodium, which is going to be 1 plus, and hydroxide is going to be 1 minus. It needs to lose 1 electron. For magnesium, it needs to lose 2 electrons, so 1 and then another 1. And then for aluminium, it needs to lose 3 electrons. Using location cars, you can determine which one would be harder to remove 3 electrons from, and therefore, which one will be less reactive or more reactive with water. I think it's quite an interesting task. Have a quick go at this. Finally, we're going to move on to chlorine. So you need to know the reactions with oxygen, with hydroxide, and with chlorine. Chlorine's quite simple. They produce chlorides. Chloride is the ion. Remember, when chlorine is bound to something, it becomes or has an oxidation state of -1. And all the products that you're going to make are going to be neutral. So you can use the crossover method to determine what the products are going to be. Now, one thing I want to show you with the crossover method really quickly, just to kind of give you a quick refresher, is this one over here. So let's have a look at magnesium. It reacts with chlorine, so put them together, we're going to get magnesium chloride. Magnesium and chlorine. Magnesium's in group 2, so that'll be 2 plus, and chlorine is in group 7, so that'll be 1 minus. Let's do the crossover really quickly. This is going to produce MgCl. Over here, I have 1 charge, so Mg, I only need 1. Over here, I have 2 charges, so therefore Cl. 2, I need, I need 2. So therefore, it's going to be MgCl2. So just as a quick reminder of how to do that. Below, I just want you to balance these reactions. These are the only ways that it can come up. And then observation-wise, again, we've got some more observations that you just need to be aware of. And again, it's just a case of recalling them. Sodium is going to be a yellow flame with a white solid product. And then you've got a little bit more interesting, like phosphorus is green-yellow flame with a yellow solid. So you can colour this one in kind of like a yellowy colour, which I'll do now for you. And then silicon is a really slow reaction. It's a colourless liquid. Have a go at practicing the crossover method, balancing, and then trying to find a way to remember your observations. These are the reactions that we need to know. It's a bit of a pain, but once you've got the skill of balancing, it should be a lot easier for you. All right, keep up the good work, guys.